My name is Pete, and I work for Atlassian on the AtlasKit team. AtlasKit is Atlassian's open source React component library, and today I'm here to talk about some future features that are coming to React, as well as my misadventures trying to recreate one of these features in the current version of React. So if you've been paying attention to the development of React or anything the React team has been saying recently, you can't really have missed this. Async rendering is coming. Now, this is a feature that has had significant investment over a long period of time. It was the main reason for rewriting the internals of React between versions 15 and 16. And more recently, we're seeing this mentioned in the release notes for 16.3, starting to deprecate some lifecycle methods that are not going to work once async rendering is a thing. So let's just do a quick recap of how rendering works today in React and how that compares to async rendering. Rendering today is atomic in the sense that once React starts a render, it's going to finish that render. And it's sequential because React kind of simply queues these renders up as it needs to, and it's going to work through this queue until all that work is done. And this is very different to how it will work in an async rendering world. In async rendering, these chunks of work are going to be prioritized and kind of a bit smaller than what they used to be. The main thing around what prioritization enables is that React can pause and reorder different chunks of work. So, for example, a render that's in response to a user typing into a text box, for example, that is going to be given much higher priority than a render from a network request coming back and you needing to update your UI in response to that. So the goal here is that React apps should always be interactive. Regardless of what device you're on, React will be able to kind of always prioritize user interactions to make sure that your React app always feels buttery. So this is an under-the-hood change. If you are not using any of the lifecycle methods that you shouldn't be, you'll be able to upgrade your version of React and have a massive boost in interactivity, as well as a performance gain as well. So a feature that is less under the hood, a bit more in your face, is what the React team is calling React Suspense. And Suspense boils down to a way for you to tell React that this component needs data for it to render. And the result of that is that now React knows that this component needs data. If the data is not available, it can actually suspend rendering that component. So let's dive in and have a look at exactly how you communicate this to React. So what we've seen in the demos is that you import this new function called createFetcher. And the way you use this is you pass this function a method that returns a promise. In this example, I am creating a character fetcher that is going to go off to the Star Wars API, and it's going to return a page of Star Wars characters. The way that you use this fetcher inside your React component is that you just plonk it in your render method like this, and then you call read, and the next line you have the data. And so the way these fetchers or these fetcher components fit into your React application is React is going to give you some tools like this placeholder component, and this lets you more easily control what your UI should look like while these components are fetching their data. So in this example, we're looking at a placeholder component, and the way this works is we're rendering our character list inside of it, and if the data is ready within a second, we'll just see the character list straight away. But if that takes longer than a second, then React is going to show the spinner, and then when the data becomes available, we will see the character list. So the goal of all of these tools and Suspense is to ensure that React apps can always show the most important content. It has this kind of theme of prioritization, and with these kind of placeholder components and the like, you will be able to easily ensure that what data is shown to the user is the most important thing to show in your app at any given time.
I see what you did there.
Thank you. So when I was watching the demo of Dan Abramov at JSConf Iceland show off Suspense, I couldn't help but think that all these things around fetching data, showing loading states, waiting for the data to come back, these are all traditionally responsibilities of the React developer. I know I've written a ton of logic that is to do with this, and I'm sure many of you here have written the same logic as well. So I was thinking, we kind of already have Suspense. Why can't this be done in the current version of React? Why can't we have the APIs that were demoed in the version at the time was 16.2? So the second part of this talk, I wanted to share my experience trying to recreate Suspense in 16.2. So the first step, just grab the first function I see and try and implement it. That was this create fetcher function that we saw previously. And so we know that this function is going to accept another method that returns a promise. And the create fetcher function should return an object with read on it that when the user calls this, they'll get the data on the next line. So we can have this kind of shape. And then we know that these fetches kind of act like a cache. They'll give you the data if they already have it. So we'll implement the most basic caching strategy in the world and add a local variable to this function. But there's still the problem of we're never assigning the data. What do we do when it's undefined? Well, we get the fetcher and we can actually execute it. So we'll call that fetcher with the arguments. And once that has resolved, we will assign our local variable data to the resolve value. But there's still the problem of we can't really return at this point. If we take it back one slide, if we remember the example in that character list component, we were calling read and then we were mapping immediately over the data. So we can't really return null, we can't return undefined, we can't return anything, so let's just do this. So this has at least kind of conformed to the shape and the contract of this create fetcher function, but we still have a problem. Remember what we're trying to do. We're trying to change the rendering behavior of React based on whether the data is available or not. And I'm kind of staring at this seemingly standalone function. I'm nowhere near React. I wasn't really sure what to do. The key, as it turns out, is to use the error boundaries feature of React. So error boundaries are the component equivalent of a try-catch statement. The way that you use these components is you add a component didCatch method to your React component, and then you render this thing, and if an exception happens in the component's child, React will bubble up this error and execute component didCatch with whatever has happened, the error that has occurred. This is pretty bad when this happens. You're not really expected to be able to recover from this very well. You're likely going to show an error message to the user and say, please refresh your browser. But that's not what we're doing in our case. This is actually the crucial link between the fetcher and getting into React. So now we can do things that affect the rendering path. So the next stage is to work out how we actually fit in this error boundary. And what I did was try and create this loading component. Now, this is another one of the components that was demoed by Dan Abramov in Iceland. And the way that this component works is it uses the children as a function pattern to simply tell the React developer whether a component is waiting for data or not. And this loading component is an error boundary. So let's step through how this component will work. If we imagine the initial render, loading is going to be false. So we're going to try and render our character list. Remember that this is the component that calls the read on the fetcher. The data is not going to be there, so we're going to throw an exception. Our loading component is going to catch this exception and re-render with, well, this is going to blow up. So the loading component catches this exception and will re-render with loading being true at this point. So we'll show a spinner, and this is going to work. The third step is what happens when the data becomes available. We want to actually have a third render here that will render the loading component with the value false, and so we can re-render our character list, and the data will be there at that point. We don't throw an exception, and this works. So there's still a bit of an issue here, though, right? Our loading component is just is this error boundary, and it has no idea when the data will become available or not. So how do we solve this? Thanks to JavaScript, we can throw whatever we want. So why don't we just throw the promise from the fetcher? So we can do something like this. And as weird as this looks, this is the key step to be able to then catch in our component did catch method. Request there is going to be the promise. And so we can just tack it then on. And then at that point, we will know the data is available. So we'll re-render with loading being false. So at this point, we have basic suspense working, right? That's pretty cool. But what about a more realistic use case? What about when a component needs to fetch new data whenever its state changes? So we can extend our example from just a simple character list to a paginated character list component with some state. So what we'll do is this paginated character list component keeps track of the current page, and then in the render method, it renders the character list as well as a simple pagination component. And that pagination component will just have next and previous buttons. Now, the way that we've seen this work in demos is that instead of calling this.setState, the developer is expected to call this.deferSetState. And that indicates to React that your next render might result in an exception being thrown. I wasn't 100%, I didn't really want to do this. I didn't want to extend component, and I wasn't sure if that approach was going to work. So I instead kind of created a component solution to this. So I created this deferred state component, and it gives you the same three things that you have in the class solution. You have a way of setting your initial state, and when it uses the children as a function pattern again to render you get the current state as well as the defer state function. And you use this in a very similar way to what we saw in the class example. Now, this deferred state component is actually very similar to the loading component that we saw, maybe slightly more sophisticated. Instead of just tracking a Boolean value of whether we're loading or not, we're just keeping track of the current state and the pending state. So we'll walk through simulate the user doing something with this component, and we'll have a look at how this works. So let's imagine that we are on page 1 already. We've fetched the data for page 1, and the user is staring at the first page of Star Wars characters. We will then assume that they click next. I don't really want to deal with the edge case of them clicking previous and trying to navigate to page 0. So We'll go next, and what's going to happen is we'll trigger a re-render. Your current state is going to be, or your pending state will be 2, and we're going to try and render a character list. Now, we don't have the data for page 2 here, so this render is going to throw an exception. It's going to throw the promise that will resolve to the second page. And then, so the user doesn't notice anything, we actually need to reset this back to the original state. So this component will keep showing page 1 while we're waiting for page 2 to come back. Now, eventually this happens, and at this point, we know we have the data, so we know we can transition to page 2. The pending state of page 2 becomes your current state of page 1, and this works. The user is now looking at page 2 of Star Wars characters. So this is pretty cool. We have rendering suspended during state changes. On the right here is a little page, a little GIF of it in action. Thank you. And the cool thing is here that if you notice, when we're navigating to a page that we've already fetched the data for, we keep that cached so it's an instantaneous change. So at this point, I was feeling really good about myself. I'm like, this is sweet. Of course, we can just have suspense right now. This makes total sense. But there are always problems, and there are problems with this as well. The main one being the way that error boundaries work. So when an exception is thrown, or an exception happens, and React is kind of bubbling up this error, looking for an error boundary, the components on the way up, the component tree underneath the error boundary is getting unmounted. And because it's getting unmounted, this means it's completely blown away. Its state is destroyed. And so the problem with this is if you have a component, say a third-party component whose state you can't control, well, this thing is going to get unmounted and its state's going to be resetting every time the user is kind of triggering one of these fetches. And it's going to appear to the user that this component is resetting. So that is a major blocker. It was okay in our toy example because we only had the current page as the entire state that we needed in our example. But in a less toy example, this would certainly be a problem. And the performance characteristics of this is garbage as well, because unmounting and mounting a component tree is going to be way more expensive than just doing a re-render. And with a large component tree, this would certainly bog down. So these are really the two reasons why React needs to provide suspense. If you imagine being inside React.component, you can more literally put a try-catch around the render method, catch the exception, tell React, hey, pause rendering this component until the data comes back. And you can also give a nicer API, right? You can add this.defer set state or whatever it ends up being. You don't have to go with this component approach that I did that it kind of forces you to lift the state out of your component and into another component. And because we're in React, we wouldn't even have to unmount the component that throws the exception as well. So I imagine there's going to be almost no performance penalty of using this feature. So what does an async future look like? We have suspense, we have async rendering, all the things. I think it looks pretty bright. Suspense is the first feature that we've seen that has kind of been unlocked by async rendering. It has been unlocked because React can now pause and go off and do something else while we're waiting for the data to come back, which just wasn't possible with the current rendering strategy in React. So I'm very excited for this to come out, and I'm super excited to see what people do with these features once they actually drop. That's all I really had to say on the topic. If you want more details, I wrote a blog about this. My Twitter is @Pete_Gleason. There's links to the repo and further detail if you're interested. Thank you very much for listening.